Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the definition and terminologies we are going to be follow on principles of data science module 1. So what is data science? So data science is nothing but an art and science of acquiring knowledge through data, and it is all about how we're going to take the data and how we're going to use it to acquire knowledge, and then use that knowledge to do the following: and make decisions, predict the future, understand the past and present, and create a new industries and product. So data science is nothing but art and science of acquiring knowledge through the data, and the data science is should be all about how we're going to take the data and acquire the knowledge, and then how we're going to do that the following, like make decisions, predict the future, understand the past and present, and create new industries and product. So this and all should be about the data science. And what are the basic classifications of the data? So normally the data is going to be classified into two types. So first one is structured data and another one is unstructured data. So sometimes this can also be called as organized and unorganized data, and which should also known as quantitative data and qualitative data. So data normally the data will be of different types. So where the data is going to be come from different sources like primary and secondary sources. And again, this primary source means the data collected by investigator and from conducting questionnaire. And so secondary sources may it should be books from internet and magazines, like this. So whatever the data is coming from these sources, so we have to be classified into four types. So first one is that structured data, and another one is unstructured data and quantitative data and qualitative data. So qualitative data means it should not have any kind of measures, and here we can able to use some of the measures here. And structure means where you can able to organize in the form of the structure, and unstructured means we should not be have any kind of the structure going to be followed. So these are the basic classifications of data. And next one is how we're going to differentiate organized and unorganized data. So what is an organized data is, so this refers to data that is going to be stored into row and column structure, where every row represents a single observation and column represents the characteristic of that observation. So unorganized data means, so this should be the type of data which should be of free form. So usually a text or raw data signals that must be passed further to become organized. So here the organized data means, so it should be referred the data that is going to be stored in the form of rows and column structure. So that should be in the form of a table. So where every row is going to represent the single observation and the column represents uh, the characteristic of that observation. So column represents the characteristic and row represent the observation. So this should be the organized data structure. And unorganized data means the data should be in free form, So usually it should be in the form of text or raw audio and then video signals. So that must be parsed to be organized. Next one is differentiate structured versus unstructured data. So the structured data means the data can be thought of observations and then characteristics. So usually organized using a table method called rows and then columns. Unstructured data. So that means the data exists as a free entity and does not allow any kind of standard organization hierarchy. So structured data means should be a thought of observations and then characteristics where you can able to organize in the form of rows and then columns. And unstructured data means it should be of free entity and does not allow any kind of standard organization hierarchy. And next one is describe about various basics of data type. So that means we are going to discuss about the qualitative and then qualitative data. So normally the data can be of two types, so quantitative data and qualitative data. So quantitative data means this can be described using the numbers and mathematical procedures, including additions. And qualitative data means this data cannot be described using the numbers and basic mathematics. And this data generally thought of being described using a natural categories and then language. So here what I'm going to say that is the qualitative data and quantitative data. So quantitative data is going to have measurements and qualitative data is not going to have any measurements. So example like weight in kgs, one of the example, and height in centimeters is another example, where qualitative data means color, hair color, so it should be black or red or brown, so it should not have any kind of measurements. And then uh, ranks, so first, second, third, like this. So this and all will be the qualitative data. So the quantitative data can be represented in the form of numbers and basic mathematical procedures, so including additions and all possible on the set. And qualitative data means it cannot be described using the numbers and basic mathematics. So normally the data should be thought of being described using natural categories and language. So describe about the nature of the data. So for that we are going to have qualitative data and attributes and quantitative data or variables. So the characteristics or traits for which a numerical value cannot be assigned is called attribute. So like gender, motivation, etc. And the characteristics or traits for which the numerical value can be assigned is called as variables like height and weight, etc. So the qualitative data means it should be the characteristics or traits where the numerical value cannot be assigned, is called as attributes like gender and motivation. And quantitative data means the characteristics where the numerical value can be assigned in the form of height and weight is that. Next one, so we'll illustrate various levels of data. So for that, we're going to have different types of data. For that, just now what I said is quantitative, qualitative, and then quantitative. So qualitative means nominal one, and then ordinal one, and then quantitative means it should be discrete data and continuous data. So what is nominal data? So nominal data means it should be Some examples like gender, so it should be a man or a woman, and hair color, it should be blonded or brown, and ethnicity like Hispanic and Asian. And ordinal data means first, second, third, and letter grades like ABC, and economic status like low, medium, and high. And quantitative data means it should be discrete one or it may be continuous one. So discrete means it should be the number of students in the class considered as a discrete one. So let it be some 100 students. A number of workers working in company, let it be 1,000. This should be an example of discrete data. A number of home runs in baseball game, let it be 50, should be also considered as a discrete data. And continuous data means it should be the height of the children and square footage of two bedroom and then speed of cars. So like this we are going to discuss different types of data. So nominal means an ordinal should not have any kind of measurements, and here we're going to have some of measurements if quantitative data. So nominal means that so it should be a gender, that should be men or women, hair color, ethnicity. And ordinal data means first, second, third, and letter grades like APC and economic statics like low, medium, and discrete data means which is going to have some of the measurements. Suppose number of students in the class, and the number of workers in the company, a number of home runs in baseball games. And continuous data means it should be height of the children and square footage of two-bedroom house and speed of the car's line. So what are the various measurement scale of the data? So normally there are going to be different uh, scales are available for representing qualitative data and then quantitative data. So qualitative data means we're going to have scales like nominal scale and ordinal scale. And for this quantitative data, we're going to have interval and then ratio scale. So these are the scales that are available for representing qualitative and quantitative data. So nominal scale, so means how it will be, and then ordinal scale and interval and ratio scale. So these are the different factors or measurements that have to be considered for the qualitative and quantitative data. So, what are the 5 steps of data science is another question. So, the data science is going follows a structure and step-by-step process that we can able to follow, which should able to preserve the integrity of results. So, some of the steps will be asking an interesting question, obtaining data, exploring data, modeling data, and communicating and visualizing the results. So these 5 essential steps are to be very important to perform the data science. So first one is that asking an interesting question. So suppose I want to extract some of the data. So how can you able to extract the data by inquiring through the persons. So asking an questionnaire can able to extract the data in the form of text. So obtaining the data. So obtaining data is next one, and explore the data from various sources. So like primary and then secondary source, and we have to model the data. It should be in the form of design. We have to model it and communicating and then visualizing the results. So these are the 5 steps we have to be followed to perform a data science. So first one is asking the questions to obtaining the data, and third one is exploring the data from various sources, primary and secondary, and we have to be model the data, and we have to be perform communicating and visualizing the results. So these are the steps what we're going to be following in data science. And next one, what are the objectives of data presentation? So the first one is that the classified data should be more easily understood. So what are the data we classify? that thing should be easily understood and should also present the data in the form of simpler form, and it should also facilitate the quick comparison, and it helps for further statistical treatment such as average, dispersion, etc. And should also detect the error easily. So these are the main objectives of data presentation. So the classified data is more easily understood and it should present the fact in the form of simpler form, and should also facilitate the quick comparison, and it should also be helps in further statistical treatment such as average, and should also detect the error easily. So these are the various forms of data object. And next one, what are the various types of classification? So if I'm going to consider the qualitative classification and quantitative classification, so again this one is further divided into different classifications like geographical classification, chronological classification, and qualitative classification. So what is geological classification? Geographical classification means so where we can able to uh, area and then the regions, various uh, areas what we are going to show on the map of Google Earth like this geographical location. So that and all we can able to classify it. So what should be the black soil region and the red soil region, and then suppose rainfall region or non-rainfall region like this. We are going to be have classification that should be the geographical classification. And chronological classification, that means suppose if I'm going to have a data in the form of text like this, so we have to be arrange the data in chronological order. So A B C and C X F E F C, that should be the chronological classification. And qualitative classification, similarly if I'm going to consider the quantitative classification, that means you have to consider discrete and continuous. So discrete in the sense you have to be make use, discrete means mm, like a number of runs, a number of runs in a cricket match, a number of runs in a baseball game, a number of runs in a number of students in the company, and number of workers in the company. That and all it should be the discrete classification. And continuous classification means where the data is going to be classified with respect to time here. So if I'm going to consider, so what should be the stock price at 10 o'clock, and what should be stock price at 11 o'clock and 12 o'clock like this, then we have to be taking make use of this one continuous classification. And what are the various advantages of data visualization? So the advantage should be it should be easier to read, and should also shows the relationship between two or more set of observations, and it should be universally applicable and has high communication power, and should also simplifies the complex data and have more lasting effect on brain. So the advantages should be very important. So of data visualization. So whatever the visualization you are representing, that should be easily understood what this representation is meant for, and you can also make the relationship between two or more set of uh, data. You can easily understood. You can easily compare also number of men's and number of women's, and universally applicable this kind of charts, and should also have high communication power. So instead of studying a lot of text, it is better to present in the form of visualization that should be easily understood, and whatever the data that is going to have complex, that should be simplified and should also be have a long lasting effect on brain also. So let's start different types of bar diagrams. So this is another question. So we're going to have simple bar and component bar and multiple bar. So normally this simple bar is going to represent single characteristics among the different variables. Suppose I want to know the number of students who are going to study. We are going to study BPH, a number of students that is pursuing MBBS, B option and B former like this. So the single attributes we have to be considered, then we have to go for the simple bar. The next one is that multiple bar. So how this multiple bar means? So for the more than two characteristics, if I want to represent for a single variable, then I have to go for the multiple bar diagram. Suppose in a group, so one, so how many number of men's and women's are there? I want to represent it. So for this, I have to make use of multiple bar diagram. So the black is going to represent men, and red is going to represent women. Similarly, in group two, the number of men and women, and group three, number of men and women I want to show. Then I have to go for the multiple bar. So, and next one is that component bar diagram. So here the component bar diagram is that, so here the bar is going to be divided into different segment, and each segment is going to represent different values. Suppose eye color, so eye color grounded is going to represent blue, and then brown, and then green, yellow, and then blue. So like this, we are going to represent different kind of colors. The same thing I want to represent in the form of component bar diagram means. So how can I able to represent? So here the size of the bar should be same. It should be almost equal to the 100%. And in group one, group two, group three, and group four. So the number of men it should be 15, 17. So 17 and remaining should be women. So similarly in group 2 the number of men are more and remaining should be women. The number of men it should be a number of women, and like this we are going to be represent all the values in it. So some other graphical representation what I'm going to have is the pie chart. So here the pie chart is nothing but a circular diagram which is going to be shown in different segments, and each segment is going to represent the frequency in a category. Okay, so the pie diagram, if I want to it should be a circular diagram. So I want to show in the form of a different segment, and each segment is going to represent the frequency in each category. So like the circular diagram I have to take, and then have to be consider different segments. So this segment is meant for ECE people, ECE students, and this is for CSE, and this is for Triple, and this is for H&S, and this is for Aero. So like this, I want to show the various segments of this. So if I want to show the values in the form of the percentage, so it should be the better visualization. So here in pie chart, we have to take a circle and then have to be calculate the percentages of each segment, what the segment is meant for, how much percentage it is covering. I want to know. It should be matched to 100%. Then have to go for the pie diagram. So another types of diagrams what I'm going to have is that pictogram and the line diagram and then cartogram like this. So pictogram means, so suppose if I want to show this number of mm, some value, I can able to represent it in the form of diagrams. So then I have to go for pictogram, and this line diagram. So line diagram means so the values which is going to be changed continuously with respect to time. So by joining all the points, we can able to obtain a line that should be the line diagram and the cartogram. So it should be also one of the picture presentation of the graphical presentation. Suppose if I want to show the number of men's in 1990, I want to show. So in India, so by taking this example, I will explain. So here this is the example. So in this example, the France, Italy, Spain, Germany, Portugal. So these are different categories. So I would like to know so how many number of people are there in France and then Italy. So instead of representing 50, I want to represent in the form of pictorial diagram. So then I have to draw simply 5 men. So each man should be equal to the 10 people. So if same thing I can able to represent in the form of bar diagram also for better visualization. So based on the application, you can able to suggest the pictogram as well. Similarly, in Italy, it should be around 60 people. So I drawn 6 pictures. So where each picture represents the 10 people. And the line chart, suppose this is the score done by Australia and this is the score done by India and South Africa, like this. So I can able to know how many number of ranks that is scored by different people. So line diagram is one of the best example of that. And so what are the various presentation of quantitative data? So the quantitative data means we have only one diagram that should be the histogram. So histogram is nothing but the graphical representation of continuously drawn bars and should be a most popular graph for the continuous variable. Okay. So histogram, then if I'm going to maintain the space between each bar, then it should be treated as a bar diagram. So if I'm not going to maintain any kind of space between this, then I have to consider it as histogram. So that too I have to construct in between the intervals I have to maintain. So in bar graph we are going to show around the variables. So that is the one of the better indication between the histogram and then bar diagram. So these are the other graphical representations of quantitative diagrams. So histogram. The next one is that frequency polygon. So frequency polygon means so once the histogram is constructed, so after joining all the midpoints of the histogram, so if you are going to join by a smooth lines by joining all the points, so the curve line what we are going to obtain is nothing but a frequency polygon. And frequency curve means so it should also say, but we are going to be joining with smooth curve, then it should be called as frequency curve and it should be called as a frequency polygon. And next one is that scatter diagram. So scatter diagram is also something different. So we're able to show it in the form of dots. And this if these dots are something closer to this linear line, so all these dots is going to have a relationship between them. And the dots which are far of that another dot, then it can able to represent it as not have any kind of relationship. And time plot is the thing where the data is going to be changes with respect to time. Then I have to go for time plot. So suppose if I want to know what should be the temperature, is suppose a temperature, I will show it with respect to time. Then I have to go for the time. So like this, we're going to have different types of presentations. And next one is that stem and leaf display. So in stem and leaf display, the data is going to be organized in the form of stem and leaf diagram. So that means if I'm going to have a data like 689, 68, 69, 72, 73, 74, 79, 91, 91, 96, 97, 91, like this. So how can I able to represent the form of stem and leaf graphics? So for 60 series I have. So for that I'm going to consider 6 as stem, and tailing disease should be considered it as a leaf of that. And similarly, if I'm going to consider 70 series, source level I'm going to take it as a stem, and for 2, 3, 4, the tailing digits what we have, that should be considered as the leaves. So like this we are going to be considered. Suppose if I'm going to have data like let me explain to another example. If I'm going to have the data like 1021 and then 932 and then 833 and 749, 742. So how can I able to establish this? So 10 and should be round off to the nearest value, that should be 2, and for 9 it should be nearest 3, and for 8 it should be 3, and 7 it should be 5, and another value what I'm going to have 4. So like this we can able to establish a stem and a leaf diagram. And next one is that a box and it's a plot. So this is the another kind of data presentation where you can able to show the highest observation and lowest observation. So based on the quartile, so then how to go for box and this plot diagram. So these are the various types of graphical representations of the data to represent it. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.